Welcome to the week where we're going to look at machine learning for language technology, or the term that's more commonly used, natural language processing. And machine learning is going to lead us into classification, which is going to be a foundation for a lot of other things that we look at and a lot of what happens in language technology. So as an introduction to this week, here are our objectives. Here are things that we're going to learn, in 1 week. First of all, to define what is machine learning, so we're going to use that technical term and get an understanding of what that is. Learn what is the basic workflow of machine learning. Get a better grasp on the mathematical foundations of machine learning, and don't worry, this is going to be very similar to some of the other math we've seen, which all comes down to foundations of statistical learning. And then we're going to distinguish between two common types of machine learning approaches or tasks. One is clustering, sometimes called unsupervised learning, and the other is classification, or sometimes called supervised learning. And we're going to focus on classification, which is one of the most common and flexible approaches of the two. So it's not the only one used in language technology, but it is one that you'll find probably more often than the unsupervised or the clustering method. So we'll focus on classification, and we'll try to get an understanding of how classification works with machine learning, and get a chance also to discuss and get some idea of the role of features of the data. How does that play into this approach, the statistical approach of machine learning, having the machine learn? Now, before we start, it's good to have an idea of where the various terminology that we're going to cover and talk about this week, the terminology running into the book, and then how that all fits together and how it fits to terminology you may read in some of the stuff you're researching for your essay or in popular articles that touch on AI and language technology. So you'll notice I say, what is AI, right? We've used the term language technology, which is a pretty broad term, and some people might use that interchangeably with AI. Sometimes they mean other things with AI, such as artificial intelligence dealing with images rather than just language. Sometimes it's meant to refer to just the generative AI models like ChatGPT or Google Gemini that have become very popular in the past couple of years. So let's get a chance here to kind of situate ourselves, kind of orient ourselves a little bit to this terminology and get a better understanding how it all fits together. And there's still a lot of terms out there that you might run into that might be used to refer to some of the same things or overlap differently. I've chosen this chart to look at because I think it covers common terms I've seen in popular literature, as well as the concepts and the ideas and the areas of artificial intelligence that we're focusing on in this class. So you can see there's this big circle, artificial intelligence, and it has this overlap with linguistics, which is where we are. And one thing I want to note, I chose this chart. There's a lot of charts out there on the internet about what is AI, how do all these things fit together. I chose this one because I liked the way it showed the overlap and the number of terms that it included, not because the relative size of the circles or the area that they cover is accurate. So that overlap of linguistics and artificial intelligence, for example, I would say is probably bigger. Most AI, at least that people use, tends to work with language, which makes sense. We probably use language a lot more than we use images or models of genetic code, for example. But linguistics overlaps, and then we have the area of language technology that we've been calling language technology, or in computer science, it's more common to refer to that as natural language processing, or NLP. Some people also refer to it as computational linguistics. Some people say that computational linguistics is something different, answers different questions. It's more of we won't go into that. We won't worry about that. Natural language processing, NLP, computational linguistics, we can use those terms interchangeably for our purposes. Sometimes people will divide NLP or computational linguistics into other subgroups. So I've often heard people refer to NLG or natural language generation. Nowadays I hear more often Gen AI or generative AI to refer to the same thing. That is programming the computer to generate something that looks like human language, which turns out to be a much more difficult task than just understanding or processing it. So sometimes NLP is used just to refer to NLU, that is the processing or understanding of human language that's been produced by humans. And sometimes we become more specific and say NLU, or natural language understanding, to contrast it to natural language generation, or Gen AI. And that's a much easier task. We've had that around for a long time, as you've seen in this class. Like, spell checkers have been around to process the correct spelling of what humans produce since at least the 1990s. Whereas natural language generation is much more difficult. It's much more difficult to get a computer to create something that is human-like than to process the limited, relatively limited data that humans produce in language. If you think about that, that makes sense. So these are some terms that you might run into. What's missing there, of course, is Gen AI, but that kind of NLG, Gen AI, and sometimes people just refer to AI when they mean ChatGPT and nothing else. So you'll run into that. But there's an idea of how those things can be split up and talked about. And we also use the term language technology in this class. Machine learning, which is what we're focusing on this week, is what I like to refer to as the main engine of artificial intelligence. Artificial intelligence has been around as a term and as an idea, talked about with those words since the 1950s. And there's been a history of it. First, we had these rule-based models up until the 1990s, and then they had the statistical models when computing power came up and we started to get data from the internet that those things were going to work. And sometimes those statistical models that are from like the 1990s, early 2000s is referred to as machine learning. And then a more advanced or more complex version, a more layered version of these machine learning models, these statistical models, were developed around 2015. And those particular models, the ones that have been the kind of state of the art since about 2015, are referred to as neural networks. You often hear that, or deep learning, which is the term I prefer to use. I think it's more accurate. So neural networks or deep learning is really a kind of machine learning, if you think of machine learning as statistical models. But there's older and there are newer ones, so again, these terms get fuzzy. But I just want to draw your attention here to machine learning. We're not going to be worrying about the various kinds. We'll look at the deep learning models a little bit later, real briefly, to get an idea of the complexity difference. But they pretty much do the same thing. And they're pretty much, again, what we've seen all the way back in the spell checkers with naive Bayes. Those are statistical models. The thing here is, as I said, machine learning is kind of the main engine of artificial intelligence. So that the size of the circle there of machine learning is probably the least accurate part of this diagram. Outside of machine learning, except for perhaps a few of the older rule-based models that you might still see applied to either simple problems or to languages which don't have enough resources or data to make the more complex statistical models work well. Outside of those, artificial intelligence is probably 99% machine learning. And if it isn't machine learning, and particularly if it isn't the older rule-based models, then you're probably talking about what sometimes is referred to as GAI, or generalized artificial intelligence, which is more of that science fiction idea of making computers as smart as humans, which is, I would suggest, rather different than just building statistical models and training your computer to be able to do them well on a specific linguistic task.